Algebra 2, Graphing Radical Functions, Concept 20 Teacher Talk. So let's start by discussing what the parameters A, H, and K will do to the parent square root function. And they do about the same thing as they do with absolute value and quadratic functions. So with the A value, if you have a positive A, the graph will open up. If you have a negative A, the graph opens down, and it causes it to be a reflection across the x-axis. If the value of A is greater than 1, then the graph will be stretched upward. If the value of A is between 0 and 1, a fractional amount, then it is a compression. And so a stretch brings that little half curve up higher than the parent, and a compress brings it down lower towards the x-axis. For your H value, it's opposite of what you think. If you see H being added, it will shift the parent function to the left. Negative H shifts it to the right. K values are what you would think, though. If you add a K value at the end of the function, that shifts the graph up from the parent, and if it's subtracted, it shifts it down. So now let's graph this function. Notice that it's 2 square root of x minus 1. So the square root function, get that what the curve is in your mind of it, the graph of it, that's a little half curve. And let's talk about the transformation. The A value is 2, so it'll be a stretch by 2. And then the H value is 1, so it's going to shift 1 to the right. So that means that beginning point will shift off the origin to the point 1, 0. Then plug in other x values and graph those, and you have a little half curve that goes up and to the right. So the domain are all the x's that are being used to create the curve, and you can just look above the curve to see that it's the x values that are greater than or equal to 1. And the y values that are being used to create this curve are all the y values that are greater than or equal to 0. So we have a limited domain and range. Let's shift gears now to the cube root function. So notice we have H and K values. So we'll have some shifting of 1 to the left and 2 down. So think about the shape of a cube root function. It's that I think of it as like a propeller shape, and it has a middle point. Normally it's at the origin, but this transformation will shift that middle point 1 to the left and 2 down. That should actually be a negative 2. There we go. And so I just plugged in points around it and a few more. So now we can see just how the shape of that curve goes. That does that little jig jog right in the middle. So domain is a set of all the x values that are being used to create this curve. So that will be all real numbers, and the range are all the y values, and eventually all the y values would be used. So the range is also all real numbers. Number 3, we're back to the square root. So the transformations, we have shifting 2 to the right and a compress by a half. So our starting point will shift over to 2, 0, and let's plug in 3 and 6. And we get those y values, and you can see we have that little half curve that is slightly lower than the curve of the parent function. We have a limited domain and range, so all the x values that are greater than or equal to 2 and all the y values that are greater than or equal to 0 are being used. Okay, now we're back to a cube root function, so we have that propeller shape, and our graph is shifting 3 to the left. So it's going to shift that middle point over to negative 3, 0. So I plug in values around it just to get the curve of that propeller shape. So our domain will be all the x values that are being used, and that's all real numbers, and all the y values that are being used. All right, that concludes our teacher talk for graphing radical functions.